let me show you this. First of all, what you need to do is you need to first go to python.org in the Windows. So we have a latest Python 13.13.5, which is a stable version as of July. So do not go for the latest one or because it is not stable. Try to choose the stable version of Python. So which I have chosen in this example is 13.3.13.5. So then download that installer, and then you need another Conda mini installer. Mini installer for Conda is like as I said you, we can install Conda also, but unnecessary package we will get it with this mini Conda installer. That's why we have used mini Conda, so it is gives you a minimum like takes the minimum amount of memory space, and also the required package. You know when you have when you know the specific packages you need to install to run your application or to run your Qiskit program, then only you go for mini Conda installer. Else, you can directly go for Conda installer, which has all the packages which can support this Qiskit programming and use for the 64-bit whatever you have, and then download that package. Then I already downloaded this package in. Yes, just a second. So this one. So I have already downloaded this package in the C folder. So you need to install this Python in your machine. Then I already have the Python in my machine, so I will skip this step. Similarly, install the Conda, mini Conda, in your machine, so that I already have this also. So I will just skip this part. So what you need to do is you need to download. I share the URL. With that URL, you can download these two softwares and just install in your machine, so that you will be able to write. Once this is installed, now you need to verify whether this is installed properly or not. Just open command prompt and then type Python with version, so that I need to confirm whether what version of Python I have installed it is coming or not. So just a second, click event. Okay, just install it, the normal software. And the one more thing you here need to remember is when you are installing Miniconda, you need to check the option called add into the path, so that your path of Conda will be added in the Python like environment variable, so that you can access it from here. So you can see that we have installed Python 3.5, 13.5, and then again if you want to check Conda, then you can just type underscore Conda minus version, so that it will show you whether your Conda is installed properly in your system or not. So with that, we have installed these two softwares, and then uh, this gives you the environment where you can start your installation. So now let me just go to the next slide. So here, so once you have the installation done for the Conda and Python, so now we are going to use Visual Studio Code for running our example. Just open the Visual Studio Code, and then what you do is okay, open the Visual Studio Code, then go to the terminal, open a new terminal. If you see the terminal, what you have here is the base one, the one what we have, and they just create a new Conda environment, so that a specific segregated environment, so that you can run your example. So I'm just creating here Conda create minus n in new environment, just with some name, like I'm going to give Qiskit uh, hyphen environment hyphen ISL. So with that, it is going to create me a new environment, a new virtual environment. So just click yes here. Just press yes, enter. Just again press S, and now. The second step after creating environment, now you need to activate your environment so that I need to install all the packages in my environment. So for that, what I can do is just type conda, then activate the name of the one what I have decided here is Qiskit environment ISL. Just type and so that it what it will do, the environment is created and then now I will be in the environment. You can see now initially it was the base environment and now it is the Qiskit environment I am into. Now with that, what I have now, I am into the environment specific to my Qiskit new environment ISL. So now what I do, I need to install my specific package, what we have discussed just now, which I need to run for my Qiskit program. So first of all, I need install conda pip install. This is a Python installer file. So that I need this Python installer file to install the packages for me, so that I can install the remaining. So it will take time to execute. Just create an environment. Eh, Let's do it again. Just create an environment, and then once you see the environment is, we are into the environment, and then just conda install pip, and then it will install. Just press S. These are the packages what we are installing here is like the minimal packages what we require for running our cascade. And for different example for different thing it might vary. So the better thing is, if you know what are the packages, create a separate requirement.txt file with all the packages, and with one shot you can install all the packages in this machine. Just in order for you to explain what are the packages used for what bit purpose, I have just did it one by one, so that I can parallelly explain to you what actually we are installing. So this will install the virtual runtime, and now this is installed. Now what we need to do is now we need to install pip install Qiskit. So with this, it will install all the Qiskit libraries in my machine. And if you want to specific go with Qiskit 2.0, or if you want to go with minus specific version, you can just type after Qiskit minus version. So it will go to the specific version. The requirement here is like when you go for version specific version, you can see here it is installed 2.1.1, because I did not use any version name here. So if I use specific version, it is going to install the specific version in my machine. Now there are certain scenarios where you need a specific version because somebody has written the program in some other version, and sometimes the compatibility issue you will get. So in that case, when we know the specific environment what it has been created for, while creating the virtual environment for your machine, you just go for the specific version what the machine already has. If otherwise, the you may get a conflict over here. So that you can resolve it later. So these are some packages which is going to install NumPy package and all these packages which is going to install with the Qiskit. Now, once we install the Qiskit, we need to install some other packages as we discussed. Some packages for plotting the graph, some packages for runtime. So now we're going to install pip install IBM IBM runtime MATLAB matplotlib. This is used for plotting the graph. When we are getting the output, just plot the graph. This is going to install. And with that also, you are getting some other packages also, and it is an entire package which is going to add all these supporting packages as well in your Conda environment. So this is, you can see the MATLAB, it is installed, and then I need to install again the runtime for IBM Qiskit IBM runtime. So with this package, what it does is like if you have a hardware which is running in the cloud, and or if you want to run that in your simulator, so that is all supported by using this runtime. So this runtime will give you the like simulation for your program, for possibilities for the simulation, and all of the support whatever is required for running your Qiskit program. So this package will give. Then the another package what we need to install is pip install that uh, pilot pilot XEXE and see. Okay, this package is used for supporting the runtime environment for IBM, and then we have some packages for installing like pip install. We will go for IP kernel. This is for PyLab. So when we are running our program in the PyLab, though we need this support for running our code in a PyLab. So PyLab kernel, so that our PyLab kernel will be installed whenever program we write. So it will be supporting that. So, but after like installing all the packages, you should make sure that you should restart your Visual Studio Code, and while writing any file, you need to select the specific virtual environment what you have created here, and then so the kernel should be initialized. Then only you will be able to access all these packages. If you are running with a, if you have created a separate environment, and but when while running the application you selected the kernel which is default kernel, then you will not get all this benefit. So you can see we are using the Jupyter notebook in this example. That's the reason we have installed this package, and then with this package installation it will allow us to support the Jupyter notebook. And also now like I'm saying that just pass the environment name whatever you have, so that it will allow you in this environment to create a Jupyter notebook. This is the like command, like pip install kernel user, and then this is actually the mistake. You need to change the name here. Quick install. It's on just the name of what you want to display in the kernel, and then just change the name here as well. The name is Qiskit environment no instead of env. Type hyphen ISL. This is the name what you wanted to give. You can give but this name should be same name as what you have given while creating the Conda environment. Just name Qiskit env ISL. Just go for ISL, and then it is, oh I missed double quotation at last. So just change the double quotation. With that, we have installed all the supporting packages what we require for this example. Hope you are following up with me. So
Yes. Yes.
this is how we are just creating. We have not yet started any program, but we are setting up our environment in the Visual Studio Code in order to run our Qiskit program. So till now, we have installed Python, we have installed Conda, and we have installed created a virtual environment, and we have installed some specific set of packages which will be useful for our example. So now let's see the another one. Now with that, again open Visual Studio Code. Just close the Visual Studio Code and then reopen, so that whatever like packages you have installed, so that it will be taken care. And then first open the terminal, then activate the Conda environment what you have created. It will just take time. You are in the base terminal now. You just activate the environment what you have created. Just type here Conda activate. I think we are in the same. Just go. Let's do the next one. Open the terminal and then just go for creating conda activate. So that your virtual environment, what we have created, the name was Qiskit-env-isl. So it will activate your conda environment. So oops, you can see here now Qiskit-env-isl. You are in the conda environment. So now let's create a new file for a program. Select the Jupyter notebook. Then here we have the Jupyter notebook. But you see here the kernel is still detecting. It will take some time to like detect all the virtual environments what is there in the current system. So once the system is done, then you can select the kernel and then you will get the environment here. You can see Qiskit and now loaded. So select the environment what we have done here, and then it still detecting. Then it will allow yes. Now you can see the Qiskit ISL is now selected with the Python 3.13.5. With that, now we are ready to see whether our Qiskit is installed properly or not with some basic programs. The first program I want to check whether my Qiskit is installed properly or not. So just I will write import Qiskit to see the my packages are loading. Still, for the first time, it will take some time. It will connect to the environment what you have created, conda environment, and then it will give you the result whether the Qiskit is installed. Let me delete once again and then go back and then import Qiskit. This is the package. Now I'm able to load and then see when I run, I get the result correct. So means this means that the package is run correctly. And now I want to see which version of the like Qiskit is installed in my machine. If you remember, while installing the Qiskit, I have not given any version number. So with this, it is taking the latest one, 2.1.1. This is the current latest version what we have in the environment. If you want to see like the latest version what we have, you can just go to Google and then type Qiskit this URL. Go to the cloud computing instance. These are the instance. I have given the GitHub link, so you can go to that link and you can see. Now, as we want to connect to the IBM cloud, we first need to create the account for this IBM cloud. Just go to the URL and then just sign up with your Google account, or you can create a new account. I just signed up here with my Google account. So it will connect to your IBM cloud instance. And now for running your program, you need one instance to be created in the IBM cloud. So here I have only one instance created already, Qiskit, and these are the instances have used already 38 seconds. Still my 9 minutes 22 seconds are remaining. As I said you that it will give you 10 minutes per month for running your instance. So I have only used 37 seconds for these examples. So I still have 9 minutes so I can create. So I am just creating a new instance here. So Qiskit ISL. I'm just going for the free option, select and then click next and then create instance and create. Oops. Okay, now here the problem what you have is with a free account I can create only one instance. Since I already have one instance Qiskit test, I cannot create another instance. So we will do this example with the existing instance whatever we have. I just showed you how we can create the instance in the IBM cloud. Actually, the instance is means that you are actually creating the quantum hardware to run your program. I think, sir, your question is answered here. Like you mentioned, what where we are actually like running our program and where it is actually using the quantum hardware in the cloud. Actually, this is the one. This is the place where when we create an instance, so it will create the supporting hardware for your IBM in your IBM account, so that you can create. So now we cannot create another instance, so we will go with the existing instance. So you can see here two names is created, and the important thing to note over here is this name, CRN name we will be using to connect to our program. So let me copy that and go back to Visual Studio Code where we have done. I just paste it here with a code block. And also I need TFS. I need the code for token view. And so from where we can get the token is, you can just open a new tab. This is the IBM hardware, and this is the token which will allow us to access that hardware. Just log into ibmcloud.ibm.com, and then just you can create a new API key. Since I have already one, so we can also create, enable, or disable the existing key, or we can also create a new. So let me go for the creating. We can create multiple keys, but we cannot create multiple instance because instance required hardware. Whereas the key will only provide authorization to that hardware. So I just created the key. I just copy the API key and let me paste over here. So now when I am running the program, I need these two things to connect to my IBM account, where the above one is nothing but instance and the second one is a token. So with that, we need to do like we need to write service equals to Qiskit Qiskit Trump time service. So there is a function which this Qiskit has given where we have two parameters. One is a channel parameter. Channel parameter should be IBM underscore cloud because we are connecting to the IBM cloud. There are multiple channels through which we can connect, but in this instance, we are going to connect with the IBM cloud. So since we have created an instance in the IBM cloud, we just create a channel, and then the token what you have copied it from the downside, I just pasted over here, and the instance name also I need to provide in order to connect to that service. So instance name would be the CRN number what I have copied from the application. So I just delete this too. I just copy. So with that, I will delete the down one also, and then just me let us run this. So I just wanted to print what are the hardwares is assigned to my service. Now with that, I am just getting the error here. The error is because you can see my Qiskit environment in the like right side is still loading. So the environment is not yet loaded, but still I am trying to connect with the Qiskit service. So which is not possible. So what we can do is we need to stop this Qiskit environment so that the Qiskit should be stable and then only we can connect. You can see in the still it is in the loading stage. So it will not allow me to connect until the loading or initialization of this env kernel is done. So it's not possible. Just what I do now, instead of that, let me go back again. So this is another, I reopened my Visual Studio. Now you can see the Qiskit environment is now stable. And now the same import statement of Qiskit service, the 2.1.1 version of the Qiskit version, and then when I same IBM Cloud and then my token and my instance when I passed the token and instance I get it from here. That is my IBM instance cloud. This Qiskit. This is the like instance name, and this is the token, like the one here, identity management. So here I get the token Qiskit. So I got the token API key here, and then that I pasted over here in my Visual Studio Code. So my Qiskit now is running. Now you can see I have two hardwares running in the cloud with my API, with my key. So I can use these two hardwares to execute my Qiskit program. I just wanted to see the hardware, which is of how much bit it can support. It is initially supporting 127 qubits, and the other one, the IBM Torino, is supporting that 133 qubits. So with that, we have seen our Qiskit environment is now like like we have installed, we have configured, and we have installed the specific packages, and we have created an account in the IBM cloud. with which is giving us the two hardware, which is nothing but IBM Princeton and IBM Torino. These are the two hardwares. So we can use this API token channel cloud. You can see the channel IBM cloud. We can connect to the IBM cloud by using the token what we have generated. So this token will allow us to connect to the specific instance of my uh, IBM cloud. The instance is this one. So this is normally the way what we do in the cloud computing. Whenever we create any like service, so every service we give will give a public key and a URL. With the public key, we will access that. We'll have the token. We'll pass this token and the URL will nothing but an instance where the actually it is installed. So now we have seen our Qiskit runtime is run and it is running. It is giving, it is connecting to my IBM cloud and it is giving my hardware. And also I am able to see how much bit it is running. With everything is fine. Now let us do one small example of bell string, bell static string. Now the same thing what I will do. I just open my terminal. This is for, I think is this the one. Okay, so now I am just running now build circuit INF. So now let me just stop here. So these are the same thing what we did it in the demo example where we are trying to connect to the service from the cloud and trying to get the instance of the hardware whatever it is initialized to our account and to run our program. So initially, just we are importing. There are some import statements like transpile and slam reaper and plot histogram. These are used for like plotting the circuit and like plotting the graph and converting the input into like output, converting the input whatever we process so that it can be like able to display the histograph. So we need some like import statement. We need to add this import statement on the top. So after running that import statement, we are actually second we are connecting to the service what we are in the cloud, what we have in the cloud for our account. So now, so with that, just run and see whether we are able to connect or not. We are able to connect to this service and we are able to get our hardware whatever we have installed in the sound. If you want to see like what are the hardware it is initialized to my account, just go to the computer resources. You can see the instance name is qtest and these are the two hardwares which is installed in my machine, and that is what I am able to see the hardware in my machine over here. And now I'm just displaying like I wanted to use. I don't want to use both the hardwares. I just wanted to use IBM Brisbane. So that is enough for me for my example for bell switch. So just I'm displaying, and I just wanted to check how much qubit my like example is for. So my backend, you can say like the number of qubits for this algorithm is IBM Brisbane. This is the hardware. So this is capable of 127 qubits. So now there is a very simple thing which we need to understand. Now, till now, whatever we discussed about connecting to the IBM cloud, creating an account in the IBM cloud, and then configuration, and then how we can get to know that whatever packages are there, it is correct for my algorithm. But now at this point, we are actually creating the circuits. Now the bell state, either it is 0 or it is 1. So the possibility of zeros and ones should be high. So even I have given an example in the initial while starting. I said that it could be 0 and it could be 1. But when I said that it is in the superposition like this, it is in the superposition, 50% of chances should be 0 and 50% chances should be 1. And this is nothing but the probability. And how do we get this probability? We get this probability only when we change our input to the superposition. Superposition is nothing but changing our input to the changing our input bit to the superposition, which gives you the probability matrix so that your quantum hardware can process and simulate to give you the result what is the most possible possibility you may get when you process this input. Now there is one like code here. You can see QC equal to circuit. I think there's some. Okay. Now you can see QC equal to circuit 2. So this means that I am creating a circuit of 2 qubits. First qubit I am applying the Hadamard gate. QC dot H is nothing but applying the Hadamard gate. Hadamard gate is nothing but, as I said, it is converting your input into superposition. And then second one, we are just applying the C naught gate. So from output bit should be 0 or 1. So now after that, as we know, we have seen the circuit diagram. We have a black box. The black box will process that request with QC, and then it will measure the output. And now just print the QC circuit. Now if you see here, so here we are not doing any processing. So that the black box the black box things we have not done here. We are converting the input Q0 and Q1 to applying the Hadamard gate, and here not gate. So there should be chances whenever any input you give it to this circuit. So the most possibility chances of measurement is the 50% chances of 0 and 50% chances of 1. So now let's continue this. And this is the circuit, and this is the transpile. So this we are using to convert the, like, converting our backend results into specific format so that we can display it in the histogram. And after that we have a sampler v2. Sampler V2 is just to run your example in a circuit, like in the form of circuit, how the input we are giving and what we need output. It will follow the circuit, whatever we have here, and then it will take the QC dot item. You can see whatever we converted QC dot T, and that translated circuit we are passing it here, because the simpler we cannot understand the normal circuit to directly if we pass here QC. So we need to translate it and then pass it to the simulator or simpler to run, so that it can run and then give the results to you. Now, now just I am running this translate and then fine. Then my sampler is will also run. It takes some time because it need to go to the IBM cloud, process it and get the result. It took 9.8 seconds, and then just print the results. Now the results are very important to see whether the program what we have done, it is correctly giving the output or not. With a bell circuit with a bell circuit we can easily say that it's a basic example. We can say that it is a 50% of chances is zeros and 50% chances of one. So now we have result in the data folder. Data, like when we get in the JSON format, the output will be in the first object of data. So we are just printing it, and then the count here it shows. We have repeated this step for 4096 times in a 2 bits. The same step in the simulation, it has repeated 4096 shots. Shots are nothing but the number of like possible combinations it has checked 4096, and then output what we got. You can see the count directory is zeros. The output, the possibility of double zeros will be 2020 times out of this 4096, and the possible of 1 1 is 2005 times out of this, and the remaining are 01 is possible and 01. Now there might a question, you might get a question over here, like why it is getting 0 1 and 1 0. But as we know, when we convert it to the circuit, it should give me the expected result is only 00 or 1 1. 50% of 00 should be there and 50% of 1 1 should be there. But in the result we can see there is 0 1 also 32 times, and then 1 0 is also 39 times. This is actually what I was speaking about. In quantum computing we never get the accurate results, because the quantum computing is an idea of processing and probabilities, where we what we do is like the possible combinations what we get, maximum combinations we get, we treat that as an output. Normally when you go for any chat gpt model, llm model, when you ask some question, it gives you some results, but it will not tell you that this result is full accurate. So as and now the time passes, as in now the LLM model will get trained. So the items like the probability will increase. That is what we are going to get in the future. So now you can say out of 4,000, I think we are getting 2,000, 2,000. Then we are the good possibility is like the possibility is very near to accuracy. But still we are getting 0, 1 and 1, 0. It is only because we are not running that in the actual IBM hardware. We are just running on a small hardware with some set of small possibilities and with a minimal processing what we have with our free account. So that only we will get it over here. So with and the account will be, and now if you see the graph over here, where is that graph? So let me go back directly here. So with that graph you can see the possibility of zeros is this, and then the same thing what we got in the data, we are just plotting that into the histogram. So the analysis will be shown in the graph, so that where the possible input whatever you give will be either 0, 0 or 1. Why? Because it is a 2 bit. The possible combination is only 4: 0, 0, 1, 0, 1 and 1, 0 and 1, 1. With that, after processing and simulating to 4096 times, it says that the algorithm says that it is possibility of 50-50 chances. So with that, we can conclude that the algorithm is working fine with the one. So with that, we this is one example where this is one basic example what we have seen. What we do now, we will take an example of the algorithm today what we have studied, like Day's Joshua algorithm, where we have discussed about taking an input with multiple inputs. If you remember, in Josh algorithm, I discussed that whatever inputs we give, it will be multiple inputs, and then after processing in a white black box, then the output will be either 0 or 1. Still, I am saying the same thing. Yeah, I will get either 0 or 1, but due to some as we are seeing here, some noises in the IBM hardware or some noises in the data, so we may definitely get some sort of output for others also. But we have to exclude that, then we have to concentrate on more possibility. Whatever we are able to take that. Normally, whenever any application it uses AI model to make the decisions, it actually sets some parameter. Like if the output is satisfying 60% of my result, like here you can say 2022, like 50% means 4096, 50% approximately, it will be 4000 2050, but we are getting 2020, so it is more than enough to say that the result is quite good. So that's the reason the AI can make the decision based on the output what you have and process your required results. So with that, what we do, we go to some other example, and here what we say is the next one, the one what we discussed today. Just a second.
साहब इनसे बोलो कोड शेयर करो बोल के स्टेप बाय स्टेप एल्गोरिथम
Okay, the one that we discussed today is uh, Dice Josh algorithm. Now, if you remember still, so before we run this program and before we execute this and then get the result and try to identify what actually it is, we need to first understand what is our output, what we are expecting from this algorithm. The main output what we are expecting from the algorithm is we will give some input, and the input we will convert into superposition, and then the output what we require, the algorithm should show that the output what we are getting is either constant or balance. But how do we know that it is a constant or balance? We have already seen the table in the previous session that if all the inputs whatever giving, it's all the inputs are same, then it is a constant. If all the inputs are other than 0, then it is a balanced one. So now let's see this, and it is also same. The first 2 3 steps what we discussed here could be same, and you can also skip the second step, uh, could be same like importing the required like libraries for this program. The first step would be that, and the second step we can say uh, the second step is actually you are communicating as, so I need to select the kernel properly. It was not selected. Just a second, it's connecting to the kernel. So it should connect to the proper kernel, otherwise the issue you will get an issue, you will not able to connect. Okay, now I think it is connected. Let me run and see. I'm able to run this. Okay, so this is the first one. Just import, and these are the common statements what we have seen in the previous also, where we are just communicating with like what we are doing here is we are communicating with IBM cloud, and then we are checking, we are saying that which hardware I should use as a backend for processing my request. So here in this example I choose my hardware as IBM Raspberry, which is nothing but 127 qubit. If you want, you can see and then run. Okay, you can see that it is running now qubit, and then IBM Raspberry 127 qubit. And as I said that if you want to see the one hardware what you are using for running your Qiskit program, you can see here the IBM Torino is using in our instance. This is the Qiskit test is our instance name, and that it is using this like hardware. There is possibility of using other hardware also, but the conversion may differ. That's the reason we are using this one. So you can also try with multiple other hardwares also, which is supporting you for doing some simulation, so you can use that hardware. These are the hardware what we got in default when we are like when we create a register, and when we register for a common free account, we are going to get these two hardwares. But if you have some paid version, you might get better hardware with more number of qubits. You can see here the qubits is now 123, and if you purchase the hardware in the IBM cloud, you might get the more number of qubits, and the more number of qubits you have, the more number of processing power you will get. So now coming back to the Visual Studio again, you can see this 127. These are two hardwares what we are going to get. So now coming back to my Visual Studio Code again. Now with that, so I am using this hardware. I just printed out which hardware I am using, just to be sure, just to be sure that whether my hardware what I'm using it is using the same one or not. So that's the reason. Just come back. Okay. So this is the one I'm going to use as a backend. I'm using this hardware for running, and it is of 177 qubits. And then just fine. These are the two hardwares. We have already seen this. So coming back to this, and then just to be sure that I'm using the correct one, just written the code, and then now here we need to hold a bit. Now we need to create a Qiskit circuit now. As you know, like n equal to 2, here I am creating one example for 2-bit Qiskit circuit for this Josh algorithm. So as I said, we need to have n equal to 2 means I am creating 2 into 2 circuit, and then when where I am creating one with XOR and one with Edward gate. So just with applying this, so it will convert it into the superposition, and then once we have superposition, just a second, maybe somewhat. Give me a minute. Hi team, are we still connected? Hello,
Yes, sir. Yes, sir.
are we still connected? We are following. I hope. I think we have.
Yes, sir. We are following.
Sure. Okay. Let me like give me a minute. I'm just
हाँ, मैसेज में। हाँ, 10 मिनट में कर दो।
Yes. So let me come back to my session. So this is the one. I think we are already in the concluding part. So with this, we are running the cascade circuit and we are applying the balanced oracle, and then we are just transplanting the existing input. The same thing what we did in the previous step, and then we are displaying the result, converting that, and then we are displaying the result. And then let me run this. Okay. Now when I run this, I see you can see that number the output is 388 and 41 is 0, and then uh, this the more number what we got is 388. Now the last thing what we need to see here, how to know whether it is a constant or it is. So here if we have in the output 00, then it is a constant function, and if you don't have 00 and then 1. Now with a small point over to discuss to wind up our session. So the constant here you can see, as I said you, there is a some error we'll not get accurate out of 4000, we are getting 3888 as the output as a balanced one, because here the output shows that it is a constant function because I have included the message called if the output includes 0, then display as a constant. So normally here the output is 41, 0 is 41. So what we do is we don't want like to have any zeros in the actual environment, actual hardware. We will not connect with 00. So we'll only go with this actual output. So that's what it proves that the Desh Joshua algorithm will give you the output with a 2 bit with zeros and ones. So with that, I would like to conclude my session. And if you have any like queries, I am there for another 5 minutes. We can discuss.
Thank you, sir. Thanks a lot.
Uh, there are many requests come up here. We need the step-by-step installation of packages and the step-by-step code for that installation. If possible, when you're free, but tomorrow, please share us so that we can share it.
Sure, sir. Definitely. I'll create an step-by-step approach for creating the package, so I can share it with sir, so you
And
can get it from.
we, I might be looking forward for your session
Uh,
because it's been
Sorry, sir. Your voice is breaking. Can you please repeat?
now.
Yes.
Yes,
Yes, sir.
it was a wonderful session. Hopefully, looking forward to for more sessions. If anybody have any questions, please go through.
Sure, sure. Thank you so much, sir. Thank you so much for your
Thank
feedback.
you once again, Mr. Tabrez Ahmed, for this highly informative and practical session. Your live demonstration and clear instructions have truly made QScript programming more approachable and accessible for all of us.
Thank you so much, sir.
With this, we conclude day 2 of our faculty development program. A heartfelt thank to you, to our speaker, Mr. Tabrez Ahmed, for delivering 4 sessions today with such depth and clarity. We also thank all the participants for your active engagement and enthusiasm throughout the evening. We look forward to seeing you again tomorrow for day 3, which promises to bring even more exciting and advanced insights into the world of quantum computing. Have a great night and thank you once again.
Thank you
Participants,
so
please,
much.
if you have any questions, you can please ask with the speaker. Thank you, sir.
Thank you so much, sir.
Welcome, sir.
Yeah, sir, I got that
Sure.
clarity about the hardware, sir. As I asked you one question.
Yes,
So
yes, definitely.
how it is using. So now I got the idea that it is using the cloud-based hardware that is IBM Brisbane and IBM Torino.
Correct.
Okay.
Yes, that's the
So
reason I said you when we see the practical session, you will get your
yeah.
answer.
Yeah. So maybe in near future we will get a hardware like separate hardware for performing these kind of things.
Yeah,
Instead
definitely.
of
Currently, it is very like expensive hardware, so that's the reason it is not yet done. So still, like Google is trying to manufacture those type of hardware. So in future, definitely you are going to get the quantum hardwares, like the normal processor what we get now in the CPU. You'll be also getting the quantum chips in
yeah.
your PC.
So obviously VLSI people will be having a scope there to design the
Definitely,
quantum computers like that chips.
yes, that's
Just like
correct.
DSP processors we are nowadays we are using, correct? To
Correct.
performing a
Yes.
specific application. So maybe in near future we will design the hardware for the quantum computing. Okay. Okay, sir.
Future is only like taking care like government and all other organization they're actively investing in the quantum computing. The reason is because the more powerful and it is also capable of like providing more security, because if you don't go in the future the if you don't use quantum computer, the other application may easily can be decrypted and your information will get leaked. So the government is more over in this quantum computer.
Yeah. Because as a VLSI designers, we are always looking for the speed. Is it clear?
Yes,
So
definitely.
definitely, computing as I have seen that one, it's most powerful and the speed is quite high compared to the normal VLSI chips. Okay.
Yes,
Thank
sir,
you,
you
sir.
are right, absolutely right. Thank you so much for your feedback.
Thank you, sir. Thank you.
Thank you so much, sir. Thank you. Yes, sir. Do you
Sir,
have any other question, please? I am still
good
here.
evening. Good evening, sir. Tabriz, sir. It was
Good evening,
wonderful,
sir.
informative session.
Thank you so
Sir,
much, sir.
I have a question, sir. I'm Dr. Mohammad Abdul Azim from UBS calling.
Yes, sir.
Sir, IBM, it's giving only a trial version, right? I mean, the free account which we are getting it for 1 month, I think. So, right, sir?
वो डाउनलोड कर लो भाई.
No, actually, it is a free account. In this free account, we are going to get only 10 minutes in
Oh,
1 month.
oh,
The one which I have used quantum hardware for processing my queries, it has used already 38 seconds. So
oh,
still 9 minutes is there. So I can use that 9 minutes till 1 month. After 1 month, again 10 minutes I will go. I'm going to get so that I can use it for some other example. But when you
oh,
go for
with
the
the
real
same
time,
account. Okay.
with the same ID, yes, the same ID.
Okay.
Per month
But
it will
we
give
are
you
getting
10
only
minutes.
20 minutes.
Per month it is going to get 10 minutes only. So next month again you will get 10 minutes.
Okay, okay, okay.
And if you want more
Okay, sir.
processing,
Thank you.
then you
Thank
can
you
go
very
for
much.
the IBM like
Thank you for the
purchased version.
information.
Thank you so much, sir, for your valuable feedback. Have a great night. Thank you.